Good evening. Hi,
Good
Anu.
evening.
So, is my screen visible?
Yes, ma'am.
Okay, great. So, this week we'll solve week 8 assignment questions. So, before that, how was the week 7 assignment for you?
I got 64 marks.
Okay. So, is that what is the maximum?
I don't know, ma'am.
Okay, no problem. So, you have doubts in any questions from week 7 that we should discuss?
Yeah, I don't know, ma'am. First question, the whatever hint you have given,
Mm-hmm.
I tried with that and I got option A, but that option A is not correct. So answer
Just
is
one minute.
yes, I got option A, but answer, option A is not correct.
I think it is B option, right? Which is the correct option actually?
No, I have to see that. But
Because one second, I'll check. Because I remember when I had solved, I got 27.275 as one of the options. So let me just check. So did you try solving using the like MATLAB or something also? Yeah, option is
this
C.
A minus BK matrix I calculated, then I took the power 12 and
Mm-hmm.
multiply by that x naught. So with that, this I got A option.
Hmm. Okay. You got option A. Hmm. So A minus BK. So A was your 1101 and B was that. And then K was this thing. So did you take K as 1 and 1 as I had told you?
Yes, yes, I have taken
Plus 1
one
plus
one.
1.
What you yes.
So you got A minus BK as this? Or did you get something else as A minus BK?
So A minus BK I got point 0.5, point 0.5, minus 1 and 0.
Correct. So that is fine.
So then
Uh,
I took that power 12 for that
yeah,
and then multiply by 10 and 5, which is a column.
correct. So you did not
In
get
that I
that.
got yes.
Hmm.
Then I got option 1.
Okay. 0.05 and 0. No, I think you would have gotten A minus BK as option 1, but you probably missed multiplying that because A minus BK is that much, I guess. Let me check one second. So mathematically, what you're saying is right. 0.05 and 0.25, okay. No, you actually get 0.05 and minus 0.275. Probably since these two are very close, might have gotten confused, but that is the right answer. You put 10 and 5. So, can you show me your like MATLAB code or something so that I can help you fix it? There may be some very minor mistake or like some calculation mistake. You solved it using MATLAB or by hand?
But by ma'am, that I have used a minus b a to the power 12 in a simple calculator. I have not used MATLAB. I have used calculator power of that
Okay.
matrix.
So, okay, so if you get a minus bk, let's say even if this thing, right? You do power 12 of this, but then you have to multiply with this x naught, right?
Yes, yes,
You did that also.
yes,
Hmm.
yes.
Okay, I let me just check, okay? So I'm doing 0.5, 0.5 minus 1, 0. How do I show you? Maybe I can get some Python script. So try this Python script, okay? I'm not very sure if, I mean, Python or MATLAB, anything is fine. So, and then you can initialize one matrix like this. Okay, just a second. A, B, and K. Okay. So I've shared this code with you. Maybe you can try and run that. Okay. So this will help you get the answer. Or let me just check if I can get a Python editor. Okay, so let me just share my screen for a second. Are you able to see my screen?
No, ma'am.
So I'm actually sharing my laptop screen, the Python editor. You're not able to see?
Not visible.
Is it visible now?
Yes, yes.
Okay. So what I've done is I put A and B. These are the values that we have, right? And then we have the K value as +1 and +1, right? And then your BK is NP dot P and K. So B and K you multiplied first. And then we have this T like some variable as A minus BK. Okay, this is what we have, right? So what I'm doing here is I'm trying to multiply this matrix A minus BK into my X that I have, which is your 10 and 5. Okay, so I do that 12 times and then I just print the answer. So this is 0.05 and 0. Minus 0.275. Is this okay?
Yes.
Okay, so I shared the same code with you also. You can just copy and keep it with you. Okay, so let's go back to the other screen. Yeah, so this is one question. What other question do you have doubts with?
Installer, ma'am, minor mistake which I could okay make it correct.
Hmm. Okay. But overall, about the like the questions and all, you were able to solve it, right? Like there's
Yes.
nothing that you were not able to approach.
But ma'am, by error, I missed the registration date.
You missed the registration date.
Yes, I have requested them
Mm-hmm.
exam
Okay.
date. So now what to do? That is my another problem which I missed out because of I thought that I will done, but no, I missed that registration date.
Oh, the exam registration date, right?
Yes.
Hmm. Maybe write to them itself. They might help you.
I have written the mail. Let us see.
Yeah. Okay. So shall we move to week 8 questions?
Yes.
Okay. So this week 8 was mostly about this stability and the barrier functions. And here also again, the questions are very straightforward. So let's see. The first question says that choose the correct option to fill in the blanks in the following definition. So it is more about the definition would be given in your slides, and you can just fill it based on whatever is available. Okay. So if you have gone through the lectures, it should be easy for you. So this question says a system has local asymptotic ability stability if a dash can be chosen such that such that is repeated. This part is less than delta and that implies what? Okay. So I think if you go through this asymptotic stability, this portion, you should be able to get the answer for that. Okay. So I think you should refer to slide number 8 for this. It's a very theoretical question, so I'm not trying to discuss it. Sorry, slide 8. Okay, but in general, do you understand what is stability, like asymptotic stability and all of that? Okay, you can let me know anyways. Um, Checking this second question, it says select the correct properties of a Lyapunov function, which is Vx, from the following options for a stable system with equilibrium point xe. So over here, your equilibrium point is xe, and the domain of system states is D. Okay, so your domain of system states is D. All right. So you have to find out the correct options, and you have to be cautious that you can select more than one option. Okay. So be careful about that. And again, for the same question, we have one slide available. Like Lyapunov function was dealt in the lecture itself. So I think if you check this part, you should be good to go, which is the slide number 14. So over here, there are two conditions given. If v is equal to 0, v of 0 is equal to 0, and vx greater than 0 for all x belonging to D, which is your domain, except 0. But 0 in this case is your equilibrium point, right? So the origin which belongs to your domain be an equilibrium point. Okay, so this is actually your equilibrium point over here. And this is again this part, right? So these are the two things which you have to check over here, but you have to make sure that you use xe as your equilibrium point. Okay, so make sure of those transitions and select the options which you feel are correct. Okay, so the next question is again simple. Let's see. It says considering system state matrix, which is X, and that is equal to xy of transpose, which is this, and candidate Lyapunov function V, comment on the stability of the system at the equilibrium point x of 0. This is your equilibrium point. Okay, your x dot is equal to minus x plus y, and your y dot is minus x minus 2y. So if your v is equal to x square plus y square, how do you actually solve the problem? So first of all, you try to get what is your v of 0 comma 0. Okay, because your origin is the equilibrium point. So you calculate that, and then you calculate v dot. So what will this give you? 2x x dot plus 2y y dot, right? And what is x and what is y dot? It is given here. So you should check minus x plus y plus 2 into y minus x minus 2y. Okay, so given this, now what we'll have to do is we have minus 2x square minus 2xy, sorry, this is plus 2xy minus 2xy minus 4y square, right? So these two cancel out and you get minus 2x square minus 4y square, which is equal to minus 2x square plus 2y square. Okay, so you will have to check what is the value of v at this origin, right? um, and then you just check that what is the like sign of your v dot, right? So v dot, you will have to check, is it greater than 0, is it equal to 0, or is it less than 0? Okay, and based on that you can, I think, choose one of the options.
V dot is always less than 0.
Okay. So you'll be able to solve this, right, based on this hint.
Yes, yes.
Okay, great. Now let's see. It says choose the correct option to fill in the blanks in the following definition. Let x is equal to 0 be an equilibrium point of the system. X dot is equal to fx. And v is a function that maps Rn to n R be a continuously differentiable function such that v of 0 is equal to 0 and v of x is greater than 0 for all x not equal to 0. Okay, so this is more of a definition, all right, and you have to check that if your origin is a globally asymptotically stable point, then what should be filling in over here. So actually if you go over here in your slides, mm, globally asymptotic, not this. Yeah, so this is the exact same question over there. So you have x is equal to 0, which is your equilibrium point. This is your differentiable function. This is the one that is mapping, right? And this is the equation that you have. Then the origin is globally asymptotic stable, right? So this is what is the question. So you can just refer slide number 19. All right. So let's see what is the next question. Okay, this is a bit tricky, but pay attention to this. It says for the described inverted pendulum, where x1 is the angular deviation theta from the upright position and u is the scaled acceleration of the pivot as shown in the below figure. The system has an equilibrium at x1, x2 is equal to 0. Okay, so which corresponds to pendulum standing upright. Okay, so if x1 is 0, x2 should be something, right? This equilibrium is unstable. Design a stabilizing controller for the system using the Lyapunov function this, and then is the system asymptotically stable? Okay, let's see how to approach this question. So you are given x1, which is your angular deviation theta, right? And then you have your x2. I mean, I'm considering it because that's how it's generally taken. That can be your angular velocity. Okay, and this x1 is equal to x2, which is equal to 0 at this point. Okay, so this is your 0. And then what is your u? U is your acceleration. So you can consider that as your input, like more like control input. Okay, so now what all things do you have to check? So what is your Lyapunov function? V of x is equal to cos of x1 minus 1 plus a of 1 minus cos square x1 plus 0.5 x2 square, right? So this is fine. And now since x1 is your theta, so what do you consider? You will, so you can actually consider that your x1 is like a small deviation. Okay, so if you do that, then your question approximation would be a bit easier. So in that case, your cos of x1 will be 1 minus x1 square by 2, and your sine of x1 will be equal to x1. Okay, so taking that, what does your Lyapunov function becomes? It becomes 1 minus x1 square by 2 minus 1 plus a minus, sorry, a into 1 minus cos square x. So what is the square of this? It will be 1 plus, hmm, just a second. So cos square x, right? Vx is cos this, and you're trying to approximate it.
What is the value of A we have to take? A is also not known.
A is not given. That's why. So depending on what is the value of A, your answer would be that. Like, I
That is
mean,
why
you
if
have to
A is,
just.
that is why, ma'am, if A is not given, so
Mm-hmm.
information is not sufficient because it all, if you calculate V dot, it all
Mm-hmm.
depends upon A then. It all depends upon A.
Actually, um, yeah, either that or can't say. Like, I'm not sure. So these two will definitely not be there because you don't know the value of A, right? So, but based on what analysis you do, depending on that, you can check that if the value of A is greater than something, your answer could be this. If the value of A is less than something, you can do that. So it could be can't say, but can't say and insufficient information are like two ambiguous options. But let's see, even if like this approximation, we'll see. I'll come back to this one later, like we'll approximate it at some point. But let me check this. So if you take this part, right, this is going to be, so at x1 is equal to 0, what is your cos? So your cos is always equal to 1, right? And even if your x is a little bit like whatever it is always going to be non-negative, right? So this is going to be your 0, or maybe I'll use this. So this is going to be your 0. And what is the value of this going to be? It's going to be greater than 0, right? Because this part is always positive number, and cos square will always be great, like less than equal to 1, right? So this is greater than equal to 0, maybe I can say that, right? And this one is always again greater than equal to 0. So based on this, you can do what is your Vx, right? If that is greater than equal to 0, or what is the sign of that, okay, and try to get at x1 is equal to 0, x1 is equal to x2 is equal to 0, right? And similarly, you can take v dot x, you try to differentiate that and do the same kind of analysis on that also. Okay, and then over there you will get some kind of equation with a, and depending on what a is there, your equation will, like your analysis will change that way. All right. Because over here also, when we are doing these things, right, x1, even if you put these as 0, right, so if you put 1 as 0, this one becomes what, 1 minus 1, which is 0. So it is that way. All right. Should we move to the next question?
Yes, ma'am.
Okay. All right. So again, this question says if x is equal to 0 is an equilibrium point for x dot is equal to fx, where f is a continuously differentiable function and a is equal to dou f by dou x at x is equal to 0, and eigenvalues of a are lambda I. I'll say this because there can be multiple eigenvalues. Then match the following eigenvalue based conditions for stability. Okay, so let's do that. So if you have the first option, that your real part of all the eigenvalues are less than 0 for all I. So this actually means that you have strictly negative real parts, right? So eventually, if you have that, so over time, like when your t tends to infinity, what happens? Your system state will decay to 0, will become 0. Okay, so that is going to be some kind of stability condition. You can check from here. Now the second one is real part of your eigenvalues are greater than 0 for at least 1 lambda I. So if your real part is greater than 0, what happens is your system state,
Unstable.
you don't have to tell the answer, it will diverge exponentially, right? So you can choose based on that option again. And then your C is actually real part of lambda is equal to 0. And yeah, so it is like at least one of them is 0, and based on that, I mean, this one is the easiest, so you can figure it out. Is this fine?
Yes.
Okay. So what is our next question? Select the correct properties of a barrier function from the following options. Again, this is a multi-choice. Multiple options are right. Okay, so here it's a very simple thing, barrier function. Whatever is the correct option, you can choose that. So maybe I can just point you to the part. It's, I think, at the end. This is the one, right? Yeah, exactly same slide. So slide number 32. Okay, moving on. Next question is to find a quadratic Lyapunov function Vx for a continuous time controlled system to be globally stable, okay, at the equilibrium point x equal to 0. We need to find a unique symmetric matrix P such that something is equal to minus Q for a positive definite symmetric matrix Q and Hurwitz matrix A. Choose an option that fits in the blank. Okay, let's see. So, what is in general your Lyapunov function? So, if this is your system, x dot is equal to ax, that's what is for Hurwitz matrix, right? So, in that case, in general, what is your Lyapunov function? It is x transpose p of x. And what is your p? Your p is a symmetric matrix. This is given over here. Okay, so you have to specify your conditions that your v of x should be greater than 0 for all x not equal to 0, and v should be equal to 0 at x is equal to 0, right? And then your v dot of x should be negative definite. So d by dt of your xt px, this should be negative. So if you want to do v dot of x is equal to x transpose of whatever you have, that should be less than x, because you have to determine your p, right? So this is the thing. So for each of the options, just try to substitute each of them and then you can check. So one of them will come as negative definite. So you can substitute your x like over here, and then yeah, I think this should also be solvable.
Yeah, the screen is not visible now, whatever you are writing.
My screen is not visible. Is it visible
That
for
after,
others?
yes, now you have to lift it up.
Oh, okay. So the screen is visible, right? I'm not writing anything.
Slide it up, ma'am, little bit. It will be visible then. Whatever you are writing is not visible now. Hello.
Yeah, yeah. So is
You
the
have to
screen
just scroll
stuck?
up,
Like, are you
scroll.
able to see?
Yes, you have to scroll up little bit so that whatever you are writing should be visible. Yes. Now it is okay.
Okay, fine. Yeah, so I think over here you can just use that, and this should help you with the
Now
question.
first v dash we have to calculate now, ma'am. D by dt of x dash p x. What is the differentiation of that?
I guess if I tell you that would be the answer. So I don't want to do that. So you have to calculate this in such a way that this should be greater than 0.
But
Sorry,
here
less
a
than.
is in this v dash. The a is not coming, ma'am. Okay, we have to.
A is over here. I mean,
Okay, so we have to.
you have to do the derivation of Lyapunov equation, then you will get this.
Okay.
Hmm. So basically, I mean, I'll just do one more step, but then you should be able to do it after that, okay? So if you
And
try to
scroll up
dig,
little bit. Scroll up a little bit.
you're not able to see
Little
my
bit.
screen, is it?
No. You have to scroll up, ma'am. Wow, that is not visible now. Slide up little bit.
The full question screen is visible to you, right? I'm writing over here on the left side.
Yes, that is not visible where you are writing.
Okay, Victor says it is visible. Maybe zoom out your screen, probably. So V dot is X transpose, okay? And then you have, so let's say P, and then d by dt of X, okay? Plus, what do you get? You have d by dt of X transpose. So you will have d by dt of X transpose and then P and X, right? So here you can just substitute X dot P X dot plus um, yeah, X transpose, you should be able to do it. So it will come X dot transpose and PX. So you can simplify, all right? I think I shouldn't solve after this. So if you do this, you'll get your answer. Is this fine?
Yes.
Okay, great. Okay, the next question is again a very simple one. It says a matrix A is an n cross n Hurwitz matrix if the eigenvalues of A, lambda I, for all I belonging to 0 to n satisfy the following. So, what is the definition of Hurwitz matrix? It is supposed to be a square matrix, right? And you should have all negative eigenvalues. So based on this, you can choose your option. Okay. Moving on to the next question. It says choose whether the following statements are true or false. So it is if a system is asymptotically stable, then it will definitely be an exponentially stable system. And the second one is more of the barrier. So the barrier certificate approaches towards infinity as the system state approaches towards the unsafe region. Okay, let's see. So you have to check the equations for asymptotically stable. What does it say and what does it claim? Okay. So over here you have, right, that as your t tends to infinity, your x of t approaches 0, right? And what is your exponentially stable? So that also has some kind of equation. So you have to check that if a system is asymptotically stable, does this mean this also? Okay. In the second one, about the barrier function, so you have to check that if your barrier function is tending to infinity, does that mean unsafe region or not? Okay, so I think you can check from some of the notes also, or you can do some kind of analysis based on that. All right. Yeah, I think it's over here itself. So you can refer these kind of examples, maybe slide 36. 36 for this, and this one you can refer the earlier slides on stability. Okay, so I think this week's assignment is a bit straightforward. So yeah, this is mostly it. If you have any questions, let me know. Feel free to type in the chat window or unmute yourself. And yeah, and if any of you do
Ma'am,
not, yeah, tell me.
ma'am, can you help me out? Because I missed the date. I have attempted all the assignments. So I have written a mail, but mail का reply नहीं आया.
I am not actually
Hello.
sure like how I can help because I'm not from NPTEL. They only will be able to help you. So,
See, अभी exam का still there is 1 month. 27th is the exam, and
hmm, hmm,
the
hmm, hmm.
where I am appearing exam
Hmm.
center is 50% always vacated. It is not occupied.
Okay.
So exam center is not an
Do
issue.
they did they not extend the deadline before?
No, no, ma'am. Actually, it is my fault. I missed out. They have given reminders also, but
Okay.
somehow I missed out the date.
Hmm.
So now the problem is if they don't allow me to appear in this exam, I don't lose anything. But again, next year I have to again appear. Then these assignments again I have to do, and I don't know what complexity will come. So if you have some link, can you help me?
Sure. You can share your mail ID in the chat window, and I'll try to
Okay,
help you
ma'am.
out. Yeah.
Thank you, ma'am. Thank you.
Yeah. No problem. So Akash, yeah, I'll upload this recording, and you will find this in the log sheet. So it will be available. Okay, you have a doubt in last week, question 10. Let's see what that is. Okay. What is your doubt? You can unmute yourself and speak if possible.
Hello.
Hello, yes. Tell me.
Ma'am, in option B, how is the transition from state B to state C is possible because the constraint is y less than or equal to 2, right?
Could you repeat the last part?
Can you go to the state diagram?
Yeah.
Yeah, the transition from B to C require y less than or equal to 2, right? The condition for
Yes.
transition is the guard condition is y less than or equal to 2, right?
Yeah, y should be less than equal to 2.
Less than
Correct.
it. Yes. But
Yeah.
in option B, the value of y is greater than 2 when it is taking transition from B to C. Y
So the
equal to
correct option
1.5.
they have mentioned is option B.
Yes, ma'am.
Okay. And you are saying that at one point it is greater than 2.
Yes, ma'am. The guard condition for transition.
Which one is greater than 2? See, A is x0, y0.
The last
And
transition from state B to state C.
so over here,
Y,
right?
yes, ma'am. Y equal to 1.5, and from when it is going to through transition, it is y equal to 3.5, which is greater than 2, right?
This is greater than 2, but uh, after you transitioned, you are in state C.
So
So when
for
you
guard
reached this
condition,
point, over here itself you transitioned, and this is the point at which you are in the next state. I mean, you are in C. So this is what is written over here.
yes. So before transition, y equal to 1.5, that we should say.
Sorry, can you repeat again?
Y equal to 1.5 is that is before transition, and y equal to 3.5 is after transition.
Correct, yes. Yeah.
So when should we check the guard condition?
So, I mean, at some point, like based on the clock that they would have chosen, right? It is increasing by uh, 1, right? And since it is less than 2, it remained in B, but the moment it increased like 1.5, maybe it increased to 2.5 and then 3.5. So the moment you became greater than 2, your state shifted to C. So I think that is what is going on over here.
Okay, so now y equal to 1.5 is a invariant condition. So when should we check guard condition?
Y is equal to 1.5 is not your invariant condition. Y is less than 2 is your invariant condition.
Yes, ma'am.
Um,
So that
but
invariant condition should be checked for y equal to 1.5.
yeah, so but your clock is moving in like one time step, right? So it is like at 0.5 time step. Like let's say this is t is equal to 2. So at t is equal to 2, you were at 1.5, and t is equal to 3, you were at 2.5. So this is like a middle value, or maybe like
Okay.
intermediary value. So
Yeah, thank you.
yeah,
Ma'am, I have given my email in my chat box.
sure, sure. Yeah. Actually, you know what? So this is increasing at a different rate altogether. Like x is equal to 1.5, then it became 2, and then it became
Yes,
3,
ma'am.
and then it is 5. So it is like from here to here it is 0.5, then it is plus 1, and then it is plus 2. And then your y
Yes.
is just increasing in. Hmm, this is weird.
Actually, both are increasing by point 0.5 only. Like, but some middle states are not mentioned, but like further steps are mentioned only.
Right, right, yeah. So I think they have just shown some value in some states. Yeah,
Yeah.
because over here also they missed like 1 point, here it's like 0.5 and 0, 1.5 and 2. So somewhere there should be x is equal to 2.5 and y is equal to 1, and then it is this, and then yeah, you're right. So they haven't shown the middle states, like the intermediary states. So any other questions from anybody else?
Ma'am, go to previous question in the same assignment.
Mm-hmm.
Not only that, next one. Uh, the definitions. No, no. Definitions of.
Which
Yes,
question?
yes. This one, ma'am. This one, and then next one, the definition. That also I got. I'm not getting confusion.
Okay. So which options do you have confusion with?
So in this, all A, B, C, D, all are correct. So I missed one in between.
Okay. So which one did you miss? Is it not in the slides properly?
Yes, ma'am. In that slide, it is not there, but I selected three, but all four are correct.
Okay. So yeah, in general, this I would suggest that go through the slides. That is a good option. But also try to get some external sources like Google or something. So read about things in general. Because
In
slides are
previous question
limited
also,
information, right?
in
Yeah.
sixth also, yes.
Hmm. Okay. But see, always like these kind of theory questions, right? Try to verify from some reference book or something like that. Because slides are condensed information, right? So,
Yes, yes, yes. That is why there is something error which we got it
hmm,
because we have not checked with some standard book.
correct. Yeah. Okay. If there are no questions, I think we can officially close the session. But I'll be here until 8 p.m. That is end of the class. So you can always stay back and ask questions. Thanks for attending. We'll meet next week 6 p.m. again.
Thank you, ma'am. Please try it from your side.
Sure. I'll try to send them an email and let's see what happens because I'm not from NPTEL, so
Thank you.
I'm sure. Yeah.
Thank you, ma'am.
Okay. No problem.